Hello class, welcome to section 4.3. I will just kind of say hello. I don't know if it's morning or afternoon when you're watching this, so I hope you're having a pleasant day. And behind me, I'll move out of the way, is all the vocabulary related to section 4.3. So I'll do a quick kind of run over. I'll pause real quick in case you need to pause the video, and then I'll go ahead and erase everything and let you catch up at your own speed. So a term in a polynomial is just a simple algebraic expression. So sometimes it can have a variable and other times it might not. And so either one of those are examples of a term. A polynomial is one or more terms. And so I don't know why I'm going to 5 every time. We see these things all the time in math. That would have 2 terms. If you have 1 term, 2 terms, or 3 terms, you do have a special name. So a monomial would be like 7w squared. This would be a perfect example of a binomial because it has 2 terms attached to it. And a trinomial would just have 3 terms, maybe x squared plus 2x minus 9. A degree is a little bit tricky of a concept. Honestly, I just wanted you to be familiar with it in case it came up in your book, in your reading, in your My Math Lab, so you'd be familiar. I'm not going to test you on these terms. They need to be things that you're familiar with, but degree does not come back up over and over and over again that often. So if it's a little confusing, it's okay. So this one's a little bit easier because it's the largest exponent in any term. So this is x to the 3rd, that's x to the 1st. Clearly 3 is bigger than 1, so this would have a degree of 3. But over here we have x's and y's within the same term. So what do you do then? You add these together. That's what I mean by combined. Even though you know that we can't add them using our exponent rules, we add them for the purpose of the degree. So this right here has a degree of 6. This term has a degree of 4. So the polynomial as a whole, we would say it is a 6th degree polynomial. We would add those only for the purpose of stating the degree. A coefficient is just simply all of the numbers in front of the variables. So this not being a hashtag for your Instagram, that being the number sign. So this would be a coefficient, this would be a coefficient. If it's not there, it's a 1, just automatically implied. This would be a coefficient there, okay? This would be a constant term because there is no variable behind it. All right, the leading coefficient would be the number in front of the degree, the part of the polynomial that is the degree. For instance, this is the 6th degree because of this piece right here. So this 6 would be the leading coefficient. So these are the vocabulary words that they go through. You're welcome to read the book and see. I try not to give you too much of a mathematical definition. I try to put a lot of the definitions in kind of a more layman's term for you, and then you can go back and use the book as a reference as needed. All right. If you've been in a math class recently, I feel like this is something that you will remember. It's certainly something that most of us would have covered in a high school math class, a high school algebra class, but for some of us, maybe not, because things have changed over how much, depending on your age and how long it's been since you've been in high school. Rules have changed over time. So the first thing we're going to look at in section 4.3 is how to combine like terms. And so our example, and I have several, and 4.3 is pretty short, so it's not going to be as long as some of those exponent ones. Maybe we have 6x squared plus 5x squared. And so when we combine like terms, we just need to make sure that our variables match up as well as our exponents. Perhaps I shouldn't have put those squares for our first example, so stay with me here. All right, so if these two things are exactly the same in both what letter it is and what exponent it is, then we can add the coefficients. Sometimes we'll add and sometimes we will subtract. So 6 plus 5 is simply 11x squared. That's the gist of it. Let's look at another one. We could have this, let's make this example A. Example B, 7x to the third plus 2x squared plus 6x plus 11x to the third minus 8x. So this one's a little bit longer. I'll kind of pause right here, let you catch up. You can even go ahead and try it if you'd like. Pause the video, see if you already kind of remember what to do from the first example in previous math classes. Both of those terms are x to the third, so we can combine the coefficient. Notice the exponent doesn't change. All that we're doing is we're adding the 7 and the 11, making it 18x to the third. And then we're looking, hey, are there any other terms with an x squared? And I actually don't see anything, so this isn't going to change. We're just going to recopy, it's just going to come along for the ride, and we're going to write that there. And then my last example, I have a 6x and then negative 8x. We could be circling ones that match, and we could be boxing those. You can do your own kind of how you want to keep those straight. So a positive 6 and a negative 8 is a negative 2, and then the x comes along at the end. Once again, it's super important that you notice that the exponent did not change. The only thing that combined are the numbers in front of those variables, those coefficients. All right, let's do maybe another one. That is a horrible Y. There we go. I'm sporting my student council shirt today. This video is being made on a Friday, and so I wanted to virtually kind of show my school spirit. We always wear our school colors on Fridays. So we are Green and Gold Panthers, and if you remember back to your high school time, and maybe you were involved in student council or involved in your school or not, it's super fun. I get to be in charge of all the school dances, typically, and the big events, the homecoming parades and all the assemblies and all of that stuff is myself and then my student council officers. So little fun facts about your teacher here. All right, so this last one, this is an X. Let me just try that again. Okay. So you also have to make sure that when you're adding or subtracting, combining terms in your polynomial, that you match the same letter with the same letter. So 5 minus 3 is 2x, and then there is no other terms with y. So you just add that to the end. Now, this is going to be my first time through my math lab, as well as maybe yours. You might know more than me. So between GCC and my high school virtual classes, I am in the process of learning 5 new software systems. So it's definitely going to be a learning curve with them. I'm pretty good at Canvas. The My Math Lab, it's going to be a little bit of a learning curve as we start class through chapter 4. And so if I can't answer your questions immediately, I will work with others to help you and figure it out, definitely. But I am not an expert as of today is April 7th. So August 7th. As of August 7th, I'm nowhere near being an expert. All right, so what if it's something like this? There are no like terms, so you can't combine anything. So if you see something like this in your homework, it's simply trying to confuse you. You just rewrite like you can't do anything. That's it. All right? Historically speaking, we write our answer in descending order. So side comment, do I have that? No, I don't even, it might come up later. Now that I'm thinking of it, if we had something like this, we would rewrite that. So you're not wrong, but we all kind of have standards, we have guidelines. The way that you would do something in a certain format in English, we have certain formats that we use in math, and that is known as descending order. So we would rewrite this starting at the highest degree and then moving down from there. There are exceptions to this rule, and sometimes it can get confusing because what happens if you have, let me erase so it's not getting overly confusing. What would happen if you have something like this? And so it can get confusing because you have both x's, you have both y's. Try to do your best to do the biggest degree at the beginning. So for instance, this has degree of 5 and this has a degree of 4. So try your best, and I'm sure my math lab has certain things where you have, the downside is the typing in of the answers, and I do understand that. I believe you'll have to type them in the format that they will desire, and that will take extra time on your part. Hopefully, once you get used to it, it'll go quicker. So you will do it in descending order to the best of your ability within that degree, with that idea of degree. All right, let me erase. We're already on the last part, and this again may be a review for you. We are going to evaluate polynomials. And so I just have a few examples here. We can do something like this. And the evaluate ones can get a little bit tricky because of those please excuse my dear Aunt Sally rules. And we need to have if x equals 3. And here I need to put in a substitution for both variables. And I'll keep our substitutions tiny so that our numbers don't blow up too much. Okay, so when we evaluate, we are going to substitute our variable with an actual value. So the problem will tell you what to substitute in. I would use parentheses, you can use different colors. The method is kind of up to you. So we're gonna start with that negative. Then I'm gonna put x, what x used to be, now I'm gonna replace it with a 3 squared. Plus 4, I'm going to replace that x with the 3 minus 9. And now we just have to figure it out. So we're going to use please excuse my dear Aunt Sally, which says that we're going to do the exponent before we multiply through by that negative 1. That is implied outside that parenthesis. So we're going to go 3 times 3 is 9, but the negative is going to change it to a negative 9. Plus 4 times 3 is 12, and then the negative 9 at the back just tacks on to the end. Negative 9 plus 12 is 3. 3 minus 9, our answer is negative 6. Over here, we're going to substitute in both for x and y at the same time. So 5, negative 1 squared times 2 minus parenthesis, we're going to have a double set of parentheses here, so we have a parenthesis there, and then the 2 comes down, and then we will have negative 1 times 2 here, like that. All right, there's a lot of 2's out there on the board. You might need to watch this one more than once. Okay, again, we're going to start. we start with any parentheses or exponents. So here, we're going to start with that exponent right there. So -1 times -1 changes that to a positive. So this whole thing becomes 5 multiplied by 1 multiplied by 2. 5 times 1 times 2 is 10. Minus this one, we are going to figure out what's inside here first. We're going to do the parenthesis before we apply that square that is attached to that whole piece. So 2 times -1 is -2, times that 2 is -4, and so we have parentheses -4 squared. -4 squared is a positive 16, but that negative hasn't been touched yet. So this is separate than this. So we have 10 take away 16, which is -6. I swear you guys, I created these just off the top of my head. Didn't intend for them to come out to be the same answer. So that's just super coincidental. We can try one of these if you'd like. And I'll leave that PEMDAS up there. And we will just make x3. Use a calculator if my numbers get too big. And we'll make y -2. So go ahead and pause the video. And you can try that on your own. Okay, welcome back if you paused. So 4 times 3 times -2 squared plus 3 times 3 squared. Start here. So -2 times -2 is 4. So we have 4 times 3 times 4. So 12 times 4 is 48. Plus, we have to do what's inside here first this time because the square is on the outside. 3 times 3 is 9. Squared is 81. 48 and 81 make 129. So if that's what you got, well done. And that concludes 4.3. So good luck on your homework and let me know how I can help you.